Hey guys, welcome back again, and let's start with the Leetcode daily challenge. Okay, so today we have minimum operations to make a uni-value grid. So we are given with a 2D integer grid of size m cross n and then integer x. In one operation, you can add x to or subtract x from any element of the grid, and we need to make all the elements of this grid equal. Okay. So we are given a grid in which there's a number at each position, fine, and we need to make all the values equal by adding or subtracting this given number x. Okay, so straightforward one thing we can see, if we have a list of numbers and we have to make all those numbers equal to any one number out of them in minimum operations, what is the most optimal way of doing this? The most optimal way of doing this thing is converting all the numbers to the median of these numbers. See, these numbers are 2, 4, 6, 8. What's the median of these? In median, if 4 and 6 are in the middle, we take 4. Okay, that's basically a simple concept to do. Like if we have 5 numbers, okay, and we have to convert all these 5 into a single number, and that single number should be out of those 5, then the median is the most optimal thing, right? Then 4 is the median. To convert all the numbers to 4, we have to add 2 here. 2 is x. Okay, well, how many operations? One operation here, one operation here, two operation here, 4 operations are total. Here 1, 2, 3, 5, the median is 2. And to convert to 2, we need to do x is 1. So 1 operation here, 3 operation here, 1 operation here, 3, 1, 1. 5 operations in total, 5 is the answer. Yeah, we can also convert them to 3 also, but we are taking the median thing, so that's why. But we cannot do it here because the output is -1, because it's impossible, because we have given x. Okay, so one condition is introduced here, otherwise it was a really simple question, and that condition is that can the number even be equal to the median, right? So how do we check this thing, that if the number can be equal to the median or not? To check it, we can do one thing, that whatever is the remainder of this x with x, this median with x, that should be the remainder of it with everybody else, right? Like if x is having remainder, like x is equal to 2 and it's having remainder with the median as 0, then the remainder should be 0 with all the numbers. If there is any number with whom the remainder is not 0, then we cannot convert this to uni value grid. Same goes for here, is 1, so remainder is itself number, remainder is actually 0, and for 2 remainder is 0 in all the cases because they all are even. So that's why, that's a additional condition we need to put in the solution. So what we are going to do is simple thing, that let's make a vector, uh, vector array, let's just say this, and 4 will get all the number out of grid into the vector. Okay, and the j loop, inner loop, fine. Okay, let's just do this, array dot push back grid I j, and then let's sort this array. Fine. After sorting this, we can get the, yeah, we can get the median, correct? So the total number of elements are n is equal to grid dot size times of grid 0 dot size, correct. This is the size, so index is n by 2 and int median is equal to array index, okay, and int remainder will be equal to the remainder with the median of the x is that median percentage of x. Now we get to all the numbers, so int answer, let's just say 0, okay. So for int I 0, we iterate through all of this vector that we have sorted. Array dot size I plus plus. What we are going to do this for each element. Firstly, we will check if the array I percentage x is not equal to the remainder what we get with median percentage x, then we will just return -1. It's not possible to make it uni-value. And if it is equal to rem, then we will answer plus is equal to absolute of the difference between the median and the number divided by x, right? I guess that's it. Return the answer. Let's see if this one works. Yeah, it does. I also have one more solution for this, like same solution. This is same concept, but I have a different approach to do the same thing. Let's try that after submitting this. Yeah, that works completely fine. So that was really easy question for today. Hardly took like 6 to 7 minutes. So the other way of doing this can be if like this thing we tried here, that the remainder with the median, it's basically that remainder with all the elements must be same. So instead of doing this, we can take as int remainder is any element. Let's take the initial element grid 0 0 percentage of x, okay. And while pushing in the array itself, we apply this condition. If this condition doesn't exist, we will exit right there. We don't have to go all the way to there, okay. So if grid I j percentage of x is not equal to rem, we will just return -1 here. And after that we do all the things. And if we are entering here, it means that the condition is not needed here. This can be removed from here, and we just need the median, and this is all we need now. Yeah, that's all we need. Answer, index, median, perfect. Yeah, that will also work. Exactly. Yeah, it does. Perfect. So the only concept, there were kind of two concepts. First was that if we have a list of numbers and we have to make all the values same, and that same value must be out of all those values, then it's optimal to choose the median, because it will take minimum operations, or minimum, we can say, efforts to convert all the numbers to the median. Otherwise, if we take any other number, it won't be optimal. There will be more operations included in that solution. And the second concept was that if we have a x here by which we can add or subtract any value, then all the values must have same remainder with x, okay. If they doesn't, then all the values cannot be converted to a single value like this, okay. If we have to convert all the values to 2, then how can 3 be converted to 2 if x is equal to 2? If we subtract it, it will go to 1. If we add this, 1 will go to 3. They cannot be 2, so the remainder needs to be same as it has with any other element, okay, or with median also. So that means that all the elements will have same remainder with x. So that's why we went with the second solution, that we find the remainder. The Time complexity is a little better, or we can say the failed use cases where the answer is -1, they will return uh, early. They will give a fast solution. Why is that? Because we will return just here. Okay, we don't have to go to this loop to return -1. We will just return here because we have a remainder, and that remainder will be same for all the elements. So we can take any element to find the remainder, and then we can compare the remainder of all the other elements with x to this remainder. Fine, and right there we can exit the question. Okay, whenever we find this condition as true. So yeah, that makes this question pretty easy. And yeah, like remembering this concept of the if we are going to convert every element to a single value within the array, then it needs to be at the median. If we have to do it in the minimum efforts or minimum operations, then it has to be the median. So yeah, that's about it. So that's it for today, and this was a really simple question, hardly 10 to 11 minutes and two solutions we have done. So that's it.